Hello, algebra friends. Today we're going to have some fun with line graphs, set notation, and interval notation. But we're going to start off with some of the basics. The inequality symbol. Now, the inequality symbol historically came from the derivation or changing of an equal sign. So we all know an equal sign is balanced, and it means that two things are the same. When one value gets larger than the other, instead of two equal parallel bars, they change the symbol to show that one side is bigger than the other. The side with the bigger opening is the side with the bigger value. Now, your elementary school teachers may have used the alligator eats the bigger number or the Pac-Man eats the bigger number, and those are all true and great, but some people just like the logic, basic explanation of why are they using that symbol. And the reason is because the bigger opening has the bigger value. So, when we look at each of these inequality symbols, we are not worried about whether to read it as, is it a less than symbol, is it a greater than symbol? What we're worried about is which side's bigger and which side's smaller. So the side with the larger opening is the larger value. The side with the smaller opening, where the point is the smaller value. And that is true for every one of these symbols. So the side with the smaller point, smaller number. The side with the larger opening, larger number. Now, if we combine those inequality symbols with a part of an equal sign, then we get larger or equal to. If we look on the side with the pointy end, this side is the smaller value, but it could be equal. And similar, smaller pointy side, smaller or equal, bigger opening, bigger value, larger or equal. What we are going to do is take these inequality symbols and use them on a number line graph and shade where all the solutions are. Solutions mean the numbers that satisfy the given conditions. So when you look at x is greater than or equal to 7, to put this graph on the number line, you have to think about what numbers make this true. Whatever number I use in place of x has to be greater than or equal to 7. That means I can use 7 exactly, because 7 is equal to 7, or I can use anything bigger, so 8, 9, 10. I could also use 7.1, 7.2, 7.001, 7.5. All those decimals and fractions are included in numbers that are greater than or equal to 7. For our graph, what we're going to do is take the number that's given, that's the 7, and put it somewhere near the middle. Count up as I go to the right, and count down as I go to the left. Then we have to make the decision. Can it be equal to 7, or can it not be equal to 7? And based on our inequality symbol, it is a greater than symbol. Not that it matters, but x is bigger than the 7, so whatever number I pick as a solution has to be bigger than the 7. Or it can be equal to 7. So if it can be equal, you're going to have a closed circle. Closed circle is when you have the greater than or equal to sign, less than or equal to sign. Closed circle is also when you use the square set brackets. Now, the rest of this graph comes from which direction from this dot shows the numbers that are acceptable to use, where x has to be greater than or equal to 7. And that would be up towards the right, the larger numbers. And that's how we graph an inequality. Let's go to the one next to it, and then we'll look at the ones underneath that are in interval notation. So I take the number 8, put that near the middle of my number line, count up to the right, so that means the negative numbers, as they get larger, like temperature, as the negative temperatures rise, it goes towards 0. So the next negative number is -7, then -6, and then -5, and then -4. As it gets colder, the negative numbers become more negative, so then -9 to the left, -10, negative 11. Now, our h value has to be smaller than negative 8, but it can also be equal to. So which direction are the numbers that are smaller than negative 8? Or if you think of temperature, which ones are colder than negative 8? And that is down to the left. Now, please understand that we are concerned about the variable and whether the variable is bigger or whether the variable is smaller. If the variable is smaller, based on our pointy side and the open mouth of our inequality symbol, if the variable is smaller, we go to the left. If the variable is bigger, we go to the right. Our interval notation is a different way of representing the same type of thing. So when we look at the next example, this would be interpreted as it can be equal to 2, and then the numbers that work start at 2 because we go left to right. So we start at 2 and continue on forever up to infinity. As an inequality, that means our x values that we're going to graph has to be greater than or equal to 2. This square bracket means it can be equal to. And the curved parentheses means it cannot be equal to. Now, whenever we're talking about infinity, infinity is the idea that numbers go forever. If I asked you to pick the largest number you can think of, I could always add 1 to it and then get another number. That's the idea of infinity, is that it goes on forever. You can never reach infinity. You never count to infinity. It's a concept. It's an idea that numbers go on forever. So we can never equal or reach it. So it's always a curved parentheses around the infinity symbol. All right, so the square bracket is like having an equal sign underneath our inequality. Since the 2 came first, that's the number I use, and I count up as I go to the right and down as I go to the left. I can be equal to 2 because I see the square brackets, and I go from 2 towards infinity, so then I'm going up to the right. Our next example comes from negative infinity and then stops at 15. So it counts up to 15. So 15 is the only number I have. I put that in the middle. Count up to the right, down to the left. The square bracket means it can be equal to. This would be interpreted as x is going to be smaller than or equal to 15. 15 would be the biggest number. Because it's a square bracket, it can be equal to. Comes from infinity, so our arrow goes to the left, showing that it's coming up from infinity and then stopping at 15. If we don't have the equal to line underneath our inequality, that means we cannot exactly equal 1. 1 is still the number I use. We count up to the right, down to the left, and I still put my circle around the 1, but this time my numbers can only be greater than 1, cannot be equal to 1. So the circle is the idea that I can pick a number as close to 1 as possible, but I have to be a little bit bigger than 1. So, for example, the decimal 1.1 is not equal to 1, but it's just a little bit bigger than 1. 1.2 or 1.01 or even closer, 1.000001. So that's the idea of the open circle, is pretending that I can get the circle as close to 1 but stay not equal to 1. The y values that I'm trying to graph have to be bigger, so I go towards the right. The variable, the y, is larger than 1. Next to it, r is less than 0. 0 is the number that goes in the middle. Count up to the right, down to the left. Open circle around the 0. The letter r is smaller than the 0, so we go down towards negative infinity, down towards the left. Open circles is when we use the greater than symbol or the less than symbol, or we use the curved parentheses. instead of the square ones. So this is saying that I'm starting at a number near -3 but not equal to -3, that's why they're curved, and heading towards infinity. Starting at -3, counting up, -2, -1, 0, counting down to the left, starting at -3 but not exactly at -3, and then heading towards infinity, going bigger. That means up towards the right. This, as an inequality, would be x is greater than -3. Not equal to, because it's an open circle, and curved parentheses. Starting at 3 and going towards infinity, which means the letters I pick for x have to be bigger than -3, because it's going towards infinity from the number -3. Our last one in this section comes from -infinity up to the number 33. So I put some numbers on my number line. And this comes from -infinity, so that means all my x's will be smaller than 33. It means 33 is the biggest number that I reach because it comes from -infinity and stops just before 33. So that means my arrow would go down towards the left. So let's take a few minutes, pause this, graph each of these 6 problems, and then hit play, and let's make sure that our answers match. So go ahead and pause it. All right, so bam, answers. So check your work. The x is bigger than -3, but it cannot be equal. X is bigger, so it goes to the right. Cannot be equal, open circle. This one, y is less than or equal to the 15. It can be equal, so I close the circle. Y is smaller than the 15. Arrow goes down towards the left. Here our m is bigger than the 0, so the arrow goes to the right. Cannot be equal. K is smaller than the 5, so it can be equal, down to the left. The square bracket member says it can be equal, so this would be translated into x is greater than or equal to -5, because it starts at -5 and heads towards infinity, which means the numbers we choose to plug in, the numbers that are solutions, have to be bigger than the -5. And then the last one over here, it comes from -infinity, so x would have to be smaller than 12. Not equal, though, because it's a curved parentheses. All right, so hopefully you nailed those. Now, when we get into compound inequalities, it's like doing 2 at once. What we're looking for here is values of x that are in between -4 and 5. So we got to make sure our number line includes all possible numbers. So I'll just start at -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So on the left end, our lowest number is -4, so I have a circle there. And it can be equal to, so I'll fill it in. On the other end, our highest number is 5, so I put a circle around the 5, but I leave it open because it cannot be equal to. This says that x is in between -4 and 5, so my shading just goes from one circle to the other. No arrow here, just from one to the other. The shading part shows where the solutions are. All the numbers in between -4 and 5 are acceptable solutions to use as x. In interval notation, we go from -4 to 5. We can include the -4, so a square bracket there. And we do not include the +5, so it's a curved parentheses there. Set notation. Now, let me tell you something about the set notation. It looks confusing, but you're not going to have to write set notation. You're just going to have to be able to recognize set notation. So set notation uses the set brackets. Usually we use the letter X because that's what was given up here in the original. We use the same letter. This element symbol, it looks like a little cursive E, but it represents the word element. So x is an element of the set of real numbers. Now when you start doing questions in your skills check, there are limitations as to what I can do on the computer. This symbol that's a capital R is the set of real numbers that we talked about on day 1. When I start typing it, it'll just be a capital R to stand for real numbers. This part of the set notation just describes which set of numbers our problem set or our question is dealing with. Real numbers, remember, means all decimals and fractions, rational and irrational, all possible numbers in between and including the integers. So every number that you can think of that's in between 0 and 1 would be included in the real numbers. The next part of the set notation is simply using the inequality that was given. So for either version of the R symbol, the inequality doesn't change. The notation for set notation just describes what set of numbers is being used to answer the question. In most of the cases that what we're going to be doing this year, we will be using the real numbers, which is the capital R. So let's do another one. Write a graph, a compound inequality for each of the following situations. Situation number 1. All real numbers that are at least -2, but at most +4. So we have to count on our number line and go from -2 all the way up to +4. As long as we encompass each end, we're good. At least -2, which means -2 is the lowest number we can use, so close the circle there. At most 4 means 4 is the highest number that we can use, close the circle there. All real numbers in between. So we go from one circle to the next. So our interval notation goes from -2 up to 4. Close circle at each end, so square bracket around each end. Set notation is the squiggles, and I explained how to write those in one of our other lessons. You do a letter S, and then the letter Z, and to close it you do the Z on top, and then the letter S on the bottom. So set notation, X is an element of the set of real numbers, so long as the lowest number is -2, it can be equal to that. X goes in the middle. Highest number is 4, and it can be equal to that. When we see our graph connecting two dots like this, X goes in the middle, lower number on the left, higher number on the right. Our inequality symbols always point to the left, makes it easy, and then the X goes in the middle. All right. This time I gave you the interval notation. See it down here? Interval notation given. So what we're going to do is graph it. I have to go from -3, 1, 2, 3, 4, up to 5. -3 has a circle around it. And do we open it or close it? Well, square brackets here say we fill it in. So we got a closed circle around -3, open circle around +5, and we connect them in between. So then how would I write that as an inequality? Well, I just told you. Lowest number goes first. That's the number on the left. Highest number goes next. That's the number on the right. Whatever letter you want to use goes in the middle. And our inequality symbols always point to the left. Now just be careful to remember whether it should be equal to or not equal to. It can be equal to -3, so include the line underneath it. It cannot be equal to 5, so leave that as it was. To do this in set notation, I just put X as an element of the real numbers, and then use the same inequality that we just wrote. -3 less than or equal to X, which is less than 5. Remember, guys, if I'm going too fast, just pause it so you can write down what you need to write down, and then hit play again so you can continue on. All right? You can go back and rewind and watch it as many times as you want. Last example for this page. This time we're given the graph. We're going to write the interval notation, the inequality notation, and the set notation. So for our graph, we see that the lowest number is 11, and it's a closed circle. Highest number is 17, that's an open circle. So our interval notation goes from 11 up to 17. Closed circle around the 11, so that's a square bracket. Open circle around the 17, that's curved. Our inequality symbols goes from 11 up to 17, and the X is in the middle because that's where the shading part is. Our inequality symbols always point down to the left. It can be equal to 11, so I include the underlined part. Cannot be equal to 17. For the set notation, I just put X as an element of the real numbers, and then copy the same inequality symbols and numbers that we just used. All right, we are almost done. Last possible option is we could have two inequalities on the same graph separated by the word or. So we're still going to put both of these graphs on the same line, but let's see what happens with the word or in between. So first one, X is less than negative 3, or X is greater than 5. Two numbers that I'm given, tell me what my number line has to go from. So negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, negative 4. So I'm supposed to put a circle around negative 3, because that's one of the numbers that was listed. It's an open circle, because it's not equal to. And this time, X is smaller than the negative 3, so it's going to go down to the left. Then I put a circle around the 5, leave it open because it cannot be equal to, and this X is bigger than the 5. So now it goes up. So there's a gap in between. That means that anytime I see this word or, chances are I'm going to have my arrows heading in opposite directions with a gap in the middle. This is going to change how we write our interval notation just a little bit. So I'm still going to use the negative 3, and I'm still going to use the 5. But since we have two non-connected parts of our graph, we will need two different intervals, one for each. All right, so the one on the left, it comes from negative infinity. So it's a curved parentheses, negative infinity. Infinity symbol is a sideways 8. This part of the graph comes from negative infinity and stops at negative 3, but it cannot be equal to. Since it's not equal to, I use the curved parentheses. The other part of the graph starts at 5, but it is not equal to 5, and then heads towards positive infinity. With the gap in the middle, we use a symbol that looks like a U. In math, it's a union symbol to unite two parts on the same graph. Set notation is the same set notation that we were just doing. We say X is an element of the reals, and then we say X is less than negative 3, or X is greater than 5. So the only tricky part about doing the OR problems, make sure you have that gap in the middle, and then the interval notation will have to have two separate parts to it. So let's try another one of those. V is less than negative 2, or V is greater than or equal to 3. So that means I need to go from negative 2 to 3 along my number line. I need to have an open circle around the negative 2, and V is smaller than the negative 2, so that's going to go down. And then I'm going to have a closed circle around the positive 3, and V is bigger than the 3, so that's going to go up. So my interval notation, we always write left to right. So the left part of my graph comes from negative infinity and stops at negative 2, or really close to negative 2, not equal to negative 2. The right side of the graph starts at 3 and can be equal, so I make it square, and then heads up to positive infinity. In between, with the OR, I always use the union symbol. As far as the set notation is concerned, that's not going to change from the way the problem was originally given. I just add in the X as an element of the real numbers, and then copy down, oops, tricking myself, V in this case. V is an element of the real numbers because they use the letter V up here at the top. V is less than -2, or V is greater than or equal to 3. All right, guys, 25 minutes. That's less than 30 minutes. That's fantastic. Rewind as much as you need. Rewatch it. Email me if you have any problems or questions, and good luck. I hope you're all doing better, staying safe, and take care.